Hi everyone, this is lesson 1 in your book. It is in volume 1, page M2, so module 2, 79. Strike a balance, strike a pose. We're going to be striking a balance and solving linear equations. We're going to be continuing to do this until we get it. And so our learning targets for today, we will write equivalent equations using properties of equality. Use property of equality to solve linear equations and justify a solution method, and a little bit about one solution, no solution, or infinitely many solutions. And again, solve linear equations with variables on both sides. All right, so if you take a look at here for our do now, we had these 1 through 4 problems. If you did not do this in class, make sure you do this now. Remember, you're always doing, it's like kind of like the reverse of order of operations. Right? Whenever you're solving for something, you're trying to undo stuff so that we can figure out what x originally was, right? So here, if we have 1/3, the way we undo that, because since it's multiplying, it's just multiplied by its reciprocal. So especially with fractions, you just multiply it by its reciprocal, and then so you could cancel those out. So we would be multiplying both sides by 3/1, or just 3. And then you would just get x is equal to 8 times 3, which is 24. If you notice for number 2, notes that that's not 2.5. I kind of saw that as 2.5, and I was like, oh no, it's not. It's just 5. So it's 5 plus x is equal to 12.7. So the way we would do that, we don't look behind it. We know that it's going to be an add subtract kind of thing. So you look in front of it and notice that's a positive, right? So because it's a positive 5, the way we make that 0, right, is going to be, and the reason why we want it to be 0, because 0 plus x is just x. So it cancels out that number. So when we say cancel out, when we're talking with add and subtract, we're talking about like making it equal to 0. So we subtract 5 on both sides, and then we get x is equal to 12.7 minus 5, which is just 7.7. All right, so don't forget to subtract on that other side. And then the next one, so these first two are like your one-step equations. So your next two, number 3 is like a 2-step equation. So if you take a look at this, this is 2x minus 9 is equal to 6. Again, first we get rid of our add and subtracts, right? Because there's no other like parentheses, exponents, nothing like that. So we got to get rid of the minus 9. In order to get rid of the minus 9, you have to plus 9, right? That's the inverse. So we add 9 to both sides, and then we get 2x is equal to 15. Right? You just bring down the 2x, and the 6 plus 9 is 15. That's what we got that. And then, okay, so 2 times something is equal to x. Is equal to 15, I meant, sorry. And then, so the way we get rid of this 2, because remember it's multiplying. It's multiplying, the opposite of multiplying by 2 is dividing by 2, right? So it's just going to be x equal to 15/2. And we're going to leave it as an improper fraction. Do not change it to mixed fractions. And then number 4, remember notice you have x's on both sides. So you want to just get the x on just one side. Okay, whether you take it to the right or to the left, it doesn't matter, right? As long as it's one of the sides, and we don't want it on both sides. So then it'll look, we'll get it to look like number 3, and then we'll treat it the way we did with number 3. So in this case, we decided to subtract 2x on both sides, because when we do that, we still get a positive x. We just get x here, and so you see it's pretty simple now. So how do we get rid of this minus 1? Just add 1 on both sides, right? Minus 1 plus 1, it cancels out. It becomes 0. So then when we get x plus 0, what's x plus 0? X, right? And then so x is just equal to 13. All right, and we're going to go on. And this is the one where we started out with x is equal to 2. And we're going to just choose any constant and add. We were using this Equality Explorer, but I'm just going to show you here like what we would do. And let me just put this on the right. So we can actually create equations. Okay, this is what you can do. So try this at home. You probably are at home. And it says, okay, so this is what some of the students did in class. Right? These were their equations that they did. And so this is what we're going to do. We'll just follow these directions. Choose any constant other than 0. Oh, nope, just kidding. Choose any constant, so any number, right? And add each side, add that constant to each side of the equation. Okay, so we're going to go like plus 7. We're going to add 7 to both sides. So what are we going to get? What's x plus 7? They're not like terms, so it's just going to be x plus 7 is equal to 2 plus 7, which is 9. Right? Do you see how this is now a one-step equation? You know why it's a one-step equation? Because it only takes one step to get back to it. So instead of adding 7, we're just subtract 7 to undo that, right? All right. So then it says we're going to now multiply each side by something, some number. So, and of course, we can't make it 0, because if it was multiplying by 0, everything's 0, x is no longer there. What's going on, right? We can't do that. So the next thing we're going to do is we're going to, let's say, multiply by, what should we multiply by? 4. So let's multiply by 4. So we're going to multiply by 4 on both sides. And so remember where you need to distribute that 4. So 4 times x is 4x. 4 times 7 is 28. Okay, so that's plus 28 is equal to 36. Ooh, now do you see? It took us 2 steps to get here, right? So guess what this is called? Two-step equation. All right, and it says right here, so it says to choose any number, and we're going to subtract the term ax. Ooh, so we can add and subtract x's as well. So let's do orange, and we'll go minus. Let's make it interesting here. Minus 3x. So minus 3x. I don't really need that equal sign there. And then let's see what we get here. So 4x minus 3x. I don't know why I wrote it under the 28. Should have written it under the 4x. So that's going to be x plus 28 is equal to, okay, these are not like terms, so we're just going to write it like this. And some of you guys may wonder, well, why did I put a plus 36 instead of minus 36? Because this minus, it belongs to this 3x. It doesn't go over to the 36. You notice the 36 is positive, which means that this is going to be a plus. Remember I told you, the plus and the positives, we're going to kind of interchange as in lingo, okay? And same thing with the minus and the negative, okay? And so here we go. Do you see how cool this is looking? So this is looking kind of complex. You know what this is called? So you guys maybe like 3-step equation. No, that's just called a multi-step equation at this point. We just go 1 step, 2 step, and then multi-step. And then it says to we're going to divide both sides by some number, right? So let's divide it by, let's be nice, and we'll divide it by 2. Let's divide it by 2. We're dividing this. Oh, let's use the color blue. Divide this by 2. Divide this by 2. So let's see here. So our answer is just going to be x over 2 plus, divide that, that's going to be 14, is equal to negative 3 over 2x plus 36 divided by 2, which is 18. Do you see? It looks really so complicated now, right? But was it complicated getting there? You're like, yeah. I'm just kidding. So yeah, that's what it's going to look like. Kind of crazy, huh? And so the way we would undo this, well, there's a couple different ways we can do that. We're just going to try this out, see if we can solve this. So I'm going to put this right up here. Okay, so first things first, I want to get rid of that parentheses here. So we're going to get rid of that parentheses, not the parentheses, the fraction. Let's call this black. There we go. So now the way we get rid of the fractions, I was going to say parentheses again. So remember, we're multiplying by the denominator, right? So we're going to multiply both sides by the denominator, which is 2. It was the same for both of them. So we're just going to multiply both sides by 2. All right. So again, 2 divided by 2 is 1, right? And 1 times x is just x. All right. 2 times 14 is 28. Is equal to 2 divided by this 2 is going to be 1 times that by negative 3 here. Give me negative 3x, or in other words, the 2's just cancel out. And then plus 18 times 2, which is 36. Doesn't this look kind of familiar? What? Look. And so notice, remember right here, we divided by 2 on both sides. And remember what I'm saying is we're undoing things, right? So how do we undo that divide by 2? We're multiplying by 2 now, right? So it's the exact opposite. Because because here we already have x, right? and then we're trying to make things more complicated. Here, we're trying to figure out X, so we're trying to make things more simple. See what I'm saying? So here, and then what we're going to do is we're going to have a couple of different choices here. So you may be like, well, is that true up here? Here we subtracted 3x, so why don't we add 3x? So let's do that. Let's keep that the same color. So this is plus 3x, just as a side note. Could you have subtracted x on both sides instead? Yes. Okay. You totally could have, but you'll still get the same answer. It's just a different way of getting there. Like, is plus 7 times 4 minus 3x and divide by 2, is that the only way to get this particular equation? No, right? There are other other ways to get there, right? But this is one of the ways to get there. So that's why there are many ways to solve this equation. So we're going to add 3x to both sides, just like, because we're undoing that subtract 3x, right? So if you think about it that way, so x plus 3x is going to be 4x. And then we didn't use a 28, so here's our 28 is equal to 36. Does that look familiar? Like 4x plus 28 is equal to 36? Yeah, right? Look, same. All right. And then the next one. So remember here, we multiplied by 4 on both sides. Well, okay, technically we would not normally multiply by 4 on both sides here or divide by 4 on both sides, but for argument's sake, we'll do it. Okay, but then I'll show you the way we would normally do it, right? So we would go divide. So let's do the opposite, because we said we're going to do the opposite. So divide by 4. And this, I mean, technically you can totally do this. And I would recommend doing it as long as all the other numbers are also divisible by 4. Because if they're not, if this is like a 27, I wouldn't recommend doing that, because then we'd have to deal with fractions. That's not, right? Because in like common denominators, we don't want that. So, I'm going to stay like this. So we're going to go 4 divided by 4, 4x divided by 4, which is just x, plus 28 divided by 4, which is 7, is equal to 36 divided by 4, which is 9. And then what? So you see the plus 7? Let's do the opposite. Well, look, minus 7. Look, Ma, no hands. So 7 minus 7, that's 0, right? So x is just what we have left. And 9 minus 7, which is just 2. Do you see how we undid all of our steps and we ended up with the answer, which is what we started with over here on the left, which is x equal to 2. Ta-da! So now let me just show you just really briefly because this is gonna may bother some people. So just know that over here, what we would have normally done, right, is 4x plus 28, because not every time that you can divide by 4 on all sides and everything will go in evenly. Like sometimes it happens, but not all the time. So what we would normally do then is, again, remember, subtract 28 on both sides, get rid of the 28. And then we would have 4x is equal to 36 minus 28, which is 8. And then what do we do with the 4? Since 4 is multiplying, we're just going to divide by 4 to undo that multiply by 4. And what do we have left is just x is equal to 2. See? Same thing, right? A different way of getting there, but still arithmetically sound, algebraically sound, I should say. And we're still using the properties. We're subtracting 28 on both sides, keeping that equal. And then we're dividing by 4 on both sides. And we still get the answer of 2. All right, this is how normally we would solve that. All right, so hopefully that was helpful in having you understand why these solving things work. And if you take a look right here, we're looking at Sarah and Ethan. Oh, if you notice, these are the different properties that we talked about earlier this week in earlier lessons. And so we got the addition property of equality. And a lot of you guys may be like, well, that's just a long name, right? But let me just simplify it down for you. Property of equality, notice, is the same for, oops, I'm not drawing straight lines here. Property of equality is the same all the way through. The only thing that is different is that the addition, subtraction, multiplication, division, right? So when do we use these? When we're adding, we use addition. When we use subtracting, we use subtraction, property of equality. You see what I'm saying? So the only part that is different is the actual operation itself, but the property of equality is exactly the same. So hopefully that clears things up a little bit, makes it a little less complicated. So now, if you notice, Sarah did the exact, Sarah and Ethan both did the same thing. They started with x equal to 2. Notice for them, they added and subtracted, multiplied, divided different things, and they got these answers, or not these equations, I should say. So we're just going to check them. All right. And so notice right here on the left, we use substitution for Ethan. Oops. I don't want to use a highlighter for that. So this is Ethan right here, and we use substitution here, and we used properties of equality for Sarah. Technically, we could use this property of equality for Ethan, and we can reverse them. It doesn't matter. I just wanted to do one way in class. So if you'll take a look here, since we start out with x is equal to 2, this x better equal 2. So we're going to substitute that in. So we're substituting x. Instead of x, we're going to put in 2. So take out x, put in 2. Or put in 2. All right. So notice I put that all in this magenta purplish looking color. And and I put a question mark on top here because we don't know. Does it equal? We're checking. All right. So 2 times 4 is 4. Nothing else to simplify there. Here we multiply first because that's the order of operations. That's what it says. And so this is going to be 1/2 times 2. Remember, if you have 2 halves, what do you have? And half an apple and a half an apple, what you get a whole apple, right? That's just 1. All right, and so that's where we get the 1. And so 5 minus 1 is 4. Notice we don't have the question mark any longer because we're not confused. We're like, yep, for sure, 4 is equal to 4. That's true. Yep, this works. Ethan did a good job. All right, let's see about Sarah, right? So we're going to just use the properties of equality. So here, we're going to remember get the x's together. So all we did was use the addition property of equality, right? So because we're adding 5x to both sides, we don't want to just get rid of the 5. We're getting rid of the whole thing. So that's what we're adding them, because minus 5x plus 5x is what? 0, right? And that's what we want. We want to cancel out to 0. And then so negative 3x plus 5x is 2x. Plus 14 is equal to 18. And now we're going to get rid of the 14. So we're going to use the subtraction. Why subtraction? Because we're subtracting. Subtraction property of equality. Okay, and then that cancels out the 14 to 0, right? And so 2x plus 0 is what? Just 2x. Now, remember, this is multiplying by 2. So the opposite of multiplying by 2 is dividing by 2. And when I say cancel out here, remember we're multiplying, which means it can't multiply to a 0, cancel out to a 0. Because what's 0 times x? 0. And we have no more x. And then we're like, where did our x go? But what's 2 divided by 2? That's 1, right? And what's 1 times x? X. So when we say cancel out, when we're talking about division, then we're talking about canceling out like it cancels to be a 1, because we know that 1 times x is just x. And that's what we want. The whole point of this is just to get x by itself. So there we go. So we still get x equal to 2. Happy days. What was our property? You thought I forgot. Remember, since we're dividing, it is a division property of equality. All right. And so here are some more properties that you should be pretty familiar with. Commutative property, which says that if you go a plus b, you can switch them and go, well, that's also equal to b plus a. Like saying 2 plus 3, is that the same thing as 3 plus 2? Yeah, still got 5 fingers right there, right? Or if we do like multiplication, 5 times 3, is that the same thing as 3 times 5? Yeah, same thing. So it doesn't matter which order we multiply those in. As long as we multiply them, we're good. And then the one thing I will say to note is the distributive property right here. So remember, the distributive property means to distribute. So what does a distributor do? Distributes things. To who? To everybody who it's supposed to distribute to. So who's it supposed to distribute to? The people inside the parentheses. So this A is the distributor, right? So A is going to distribute the A to B as well as to C, so that you end up getting A times B, right here, AB, plus A times C, which is AC. That's what that would end up being. So notice that the A was distributed, right? Distributed to both the A and the C, B and the C, sorry. All right, so we're going to try this one right here. If you take a look at B, right, we're going to have to use some distributive property here because we need to get rid of those parentheses. So 3 times 2x, so we're going to distribute that out. So 3 times 2x is going to be 6x, right? Plus, if we say 1, the 3 did not do its job, right? Because it needs to also distribute to the 1 as well, right? So 3 times 1, which is 3, all right? So these are related. These are related, okay? Except, again, they are both, the 3 is inside both of them, right? Because 2 times 3, 6. 3 times 1, 3. Okay, and I was using blue. So this equals 4x plus 6. Note that this 3 did not distribute to the 4x and the 6 because there's no parentheses around there. So whatever's inside the parentheses, that's what it distributes to. Anything outside of it, it don't care. All right. So we're going to get the x's together. What we're going to do, subtract 4x on both sides. If you were like, oh, subtract 6x on both sides, you can. Just, I'd rather not for me because I want to keep my answers positive, or my resulting answer. So a 6x minus 4x is going to be 2x plus 3 is equal to 6 because it does cancel out. Again, what do we do now? Subtract 3 on both sides, and we get 2x is equal to 3. Here's my arrow. I always run out of room. 2x is equal to 3. So now how do we get rid of that 2? Just like how we get rid of any multiply by 2. Divide it by 2. And then your x is equal to 3 over 2. Just like that. You're going to leave it as that improper fraction. So remember, it says to justify. So remember that first step right here? Subtraction property of equality. Second one right here, what do we do? Subtract, right? So subtraction property of equality. And then next, what do we do? Divide. So division property of equality. See how that goes? All right. The only thing I will say here is note that there's a plus in between the parentheses and this 2, which means it's not distributing because it's not multiplying. Okay, so this one is actually just, you're going to be doing, what is it called? You are just going to you can distribute the plus, but that doesn't change anything. So you can actually just drop these parentheses. You don't need them because there's nothing to distribute. It's can be there, but it's not necessary. It's kind of useless. Okay, so yeah, so this is, let me just show you. So try this one. If you did not do this one, well, nobody did this in class because we didn't do this in class. So let's try this out. I'm going to just simplify that right-hand side. So it's just going to be, let's make this black. So 1/2 x minus 6 is equal to, well, I like to have my x's first. So I don't need these parentheses. So it's just 2x plus 2 plus 1, which is going to be 3. All right. And I can do that because technically these don't need to be there because there's nothing outside here to distribute. No multiplication, right? So what I'm going to do now is I'm going to get rid of this fraction. How do we do that? Let's multiply by what? The denominator. So we're going to just multiply everything. I'm being a little lazy here. I should technically do it for both sides, but I'm just saying everything. That's why everything's in the parentheses by 2. All right. So everything is multiplied out. So 2 times 1/2 is just 1. Don't forget our x. So 2 times 6 is minus 12 is equal to 2 times 2x, which is 4x, and 2 times 3 is going to be 6. Notice everything was doubled, right? Because it's times 2. That means double, right? So we know we did our job then. Let me just copy this down. If you did not pause and try it yourself, do it right now. Try it out. All right, and then we're going to get the x's together. In this case, I could either subtract x on both sides or subtract 4x on both sides. It's up to you. But for what I would do is I would just, for me, my choice is subtract x, right? Because that's easier to subtract than go like x minus 4x, which goes into negatives, which we can do. But, if I have a choice, I wouldn't do it. It doesn't matter. Is equal to, it's your preference. All right, and then from here, gonna subtract 6 on both sides. And so negative 12 minus 6, what's that? We're gonna get more minus, more negative, right? So we're gonna be at negative 18 is equal to 3x. And then how do we get rid of that 3 in front? Divide, right? So you're gonna just get negative 6 is equal to x, or I'm gonna just flip that and just go x is equal to negative 6. There we go, because standard practices, we have our unknown on the left. All right, and these are other ways that you could solve these problems, solve this particular problem. So if you want to take a look at that, that's what I always like doing, is make sure that your answer is -1, right? But the process is important. It's an interesting one. All right, I'm going to go down to, what was it here? Over here, the talk. So this is on page 86, all the way towards the end of the lesson, excuse me. So here we have the properties that we listed, trying to see what they did, right? So here, if you notice, we have parentheses on both sides. We need to distribute both of those. So we're distributing the -1/3 here, right? And that's what we say distributive property, and -5 here. What I would do if I was studying this, I would just copy down this problem and then try to do it on my own on another sheet of paper, or maybe over here on the left, right? Your method may be a little bit different, but if you're using the property of equalities correctly, you should get the same answer as -4. All right, and then if you notice right here, what they did was add 5x to both sides. So they could have added 2x on both sides, but they decided on the 5x. And so that's the addition property of equality. And then what do? You got to subtract, right? Because you got to, what they're doing is getting rid of that 7 because the x is on the left, right? And so subtract 7 on both sides, which is the subtraction property of equality. And then you get 3x is equal to -12. And so the way you get rid of that 3 in front of x is divide. So division property of equality. And that's going to be equal to -4. Dun, dun, dun. So now we're going to try that. So they gave us the property, and we're going to do the work. If you notice right here, they're saying that this result right here is going to be the result of multiplication property of equality. So I notice we have fractions. So I'm going to multiply both sides by that fraction, or the denominator. I'm going to multiply both sides by 3. So I'm trying to be really good by doing multiply by 3 on both sides. So 3 times 5x is 15x. 3 times 7 is going to be 21. So plus 21. That plus is from there above, equals. Now remember, this is just one big fraction. I know it looks like more complicated than that, but it's just a big fraction, right? So this divided by 3 and this multiply by 3, they're going to cancel out. That was the whole reason why we multiplied by 3 in the first place, right? So they would cancel out. So you get just whatever the top is, which is going to be -15x minus 1 plus, well, these 3's also cancel out, and all we have left is the 4. All right. So what do we do now? The distributive property, but there's nothing to distribute. Maybe they put the 3 out here. I don't know. So I'm going to just simplify this at this point. So we're going to get 15x plus 21 is equal to -15x. This is going to be -1 plus 4, which is going to be plus 3, right? So I'm going to just be like, cancel that out and go simplify. And then, oh yeah, that was our associative property saying that they did this a little different than what I would have. I'm sorry. We're just going to skip down to here. So now, what do we do now? It says the subtraction property of equality. What would we subtract? Subtract the 15x, because normally we'd like to have the, what is it called? The x's on one side. So let's do that. So subtract 15x on both sides. Not how I would have done it, but that's okay. And we would get 21 is equal to -30x plus 3. maybe they were doing something else. Maybe they were subtracting 3 on both sides. Let's try that out. Because the next stuff is not going to work out. I'm going to tell you that right now. So you could have totally done it that way, the way we did it. But anyways, so as we're subtracting, let's subtract 21 on both sides. All right, and then we would get 15x is equal to negative 15x, and that's going to be minus 18. And it says addition property, so let's go addition. We got this. Remember, addition is going to be, I'm going to write this small. So I don't know why I'm writing it. Yep, no, we can do that. So plus 15x plus 15x. And then we're going to get 15 plus 15 is going to be 30x is equal to, cancels out, negative 18. And then it says division property. Well, we got to divide the 30, right? So here, divide 30, and we get x is equal to negative 18 over 30. You're like, wait a minute, Miss Lee. That says negative 3/5. I can see that. So that's the same thing. So how can we simplify? I hope so. Because I did something wrong. So what goes into both 18 and 30? Not 5. Shall we try 3? Right? Because we know 3 goes into 18. So 3 goes into 18 how many times? So we're just going to divide by 3 for both of them. Divide by 3, divide by 3. So that keeps it the same equivalent, right? So that's going to be negative 6 over 10. Can we simplify that some more? Shall we divide by 2, right? Since they're both even. And what would we get? So negative 6 divided by 2 is negative 3 over 10 divided by 2, which is 5. What? It's the same thing. Yay. Okay. All right. Hope that was helpful for you. We will be practicing, we'll be continuing to solve for x. And remember that this stuff is going to follow you all the way through geometry and algebra 2, pre-cal, calculus, all of that. You will always be solving for x. Always. We always solve x's problems. All right. See you later. Bye.